Good afternoon to you all. Good afternoon to all attendees. I'm sure I am visible and I'm audible to all of you. And today we are over here with the UEM Jaipur ACM student chapter organized in association with Cisco. It is an Eminent Speaker program by Mr. Kaarthik Sivakumar, who is the principal engineer of Cisco Systems. So because it is in association with ACM, it is an ACM webinar. So briefly about ACM, I need to speak out. The Association for Computing Machinery, ACM, is the world's largest scientific and educational society through different local chapters, amongst which our UEM Jaipur ACM Students chapter also stands strong. ACM delivers resources that advance computing as a science and a profession. ACM provides the computing field's premier digital library and serves its members and the computing profession with leading-edge publications, conferences, and career resources. ACM brings together computing educators, researchers, and professionals to inspire dialogue, share resources, and address the field's challenges. As the world's largest computing society, ACM strengthens the profession's collective voice through strong leadership, promotion of the highest standards, and recognition of technical excellence. ACM supports the professional growth of its members by providing opportunities for lifelong learning, career development, and professional networking. Our University of Engineering and Management, UEM Jaipur, which was established in 2011 by an act of state government of Rajasthan, is established by IEM Trust, Kolkata, which is the oldest self-financed institute of West Bengal, and accredited and socially accredited the best self-financed institute of West Bengal. UEM Jaipur has been in service right from 2011, and now 5 batches have passed out and the students are doing good. UEM Jaipur ACM student chapter was founded in the year 2014, and from then onwards the students are all giving their best to perform the duties of an ideal student chapter. Now I would like to take this opportunity to extend a very warm welcome to our honorable guest, Mr. Kaarthik Sivakumar. Mr. Kaarthik Sivakumar is the principal engineer of Cisco Systems, working on software for enterprise products. He has worked at Cisco for more than 12 years, spanning the areas of routing and forwarding, distributed systems, broadband gateways, optical networks, and secure and trustworthy systems. He spends his time working on trustworthy systems for enterprise platforms, as well as mentoring and training young engineers. Mr. Kaarthik holds 2 patents and has published blogs on the security technologies in Cisco's service provider products. Here he is going to talk on security and trust, and I will just leave over to Mr. Kaarthik now. Sir, we welcome you. It is an honor for us that you are over here, and our faculty members, our students will be highly enlightened with your speech. In fact, they are eagerly waiting to hear from you. From here, it's all over to you, sir, to present your topic on security and trust. Thank you so much.
Thank you very much, sir, for the introduction. It's great to be here. Thank you very much for inviting me. So the topic we're going to talk about is security and trust. So let's say the agenda is we'll first look at a few attacks and more attacks that are happening. The second topic is about how to defend ourselves against these attacks, and the third is on the topic of trust. So what is trust? How do we measure trust, and so on? So let's start the topic with attacks and more attacks. So this is a book, and I strongly recommend reading this book. Kevin Mitnick, the author of the book, is an original hacker from the 1980s, and then now he's a researcher, is a security researcher. So he had written this book in which he says that most of our security is like the candy, is like a gems candy. On the outside, it is very hard, but when you have a small break in there, a little bit of crack in there, on the inside, it is very soft and very chewy. Almost all of our security is like this. We expect that some firewall or a password will protect us, but that is not enough, because all of that can be easily broken. And the moment that the outer layer is broken, the inner layer is completely unprotected, absolutely unprotected, and it is easy for anybody to come in. So if you get a chance, Please do read this book. It's an excellent book that I would strongly recommend. So let's take a look at some of the items in the news over the last few years. If you've seen, lots of people are getting hacked, including government agencies. The Prime Minister of France, the President of France, Germany, and the US, and China, and Russia, and so on. A lot of attacks are happening. And Edward Snowden was a whistleblower in the US. He sounded the alarm about how the US spy agencies were tracking and were hacking their own citizens and others, and a lot of these news came out, and we were all thinking, how do we deal with this? So at that time, the United States Computer Emergency Readiness Team, US CERT, they put out a notice saying that organizations can no longer rely on perimeter devices. A perimeter device is like a fence. You try to put up a fence, but that's not enough. The perimeter devices are not enough to protect the network from cyber intrusions. We need network infrastructure security. We need what is called defense in depth. Defense in depth. So there needs to be defense at every layer of the network, every layer of the system needs defense. So let's start looking at a few attacks, and then we'll see how to go from there. So types of attacks. We'll start with attacking the end system, IoT devices. Of course, a lot of the IoT devices are very cheap devices, and so they don't have much protection at all. They almost all use the same passwords. They have very bad cryptographic algorithms, and so on. And of course, we always have Windows and Linux and the Mac desktops and laptops, and now we have all of our phones, Android and the iPhones, and they all can be easily attacked. And there's a lot of information, especially on our phones. We store a lot of personal information, and when we have those phones being attacked, then we lose a lot of that information, a lot of our bank information, credit card information, financial, as well as a lot of information about our life is on our phones now. So that's the first kind of attack, where people try to attack the end system. But in order to attack an end system, you need to target lots and lots of devices. Can we do better? Can the attackers, the hackers, do better? And what they now do is they attack the routers that come in between. So let's say you have a home Wi-Fi router. If I target that Wi-Fi router, then I don't have to target all the devices in your house. I don't have to target every computer or every phone. I just have to attack the router and capture the router. And once I've done that, I can analyze all the traffic that is going through that router, and I know what everybody in your house is doing. But imagine if I could do that for a university or an office or a big enterprise. Or more importantly, what if I can do that for a government institute, for a defense organization? What if I attack the defense organization, the routers in the defense organization? I can get all the information that are flowing through those routers, and that includes from every device that is connected to that router. But let's think even bigger. What if I try to attack not just a single router, but large scale servers on the entire network itself? So what I can do is I can trigger what is called a denial of service and a distributed denial of service attack. So I can target a whole bunch of devices on a single server or a single network, and I can bring the whole network down. We'll take a look at how that works. But let's think even bigger. I can attack the supply chain. Now imagine all of your products, they come from some factory somewhere. So and nowadays, of course, a lot of our products come from a single country. So imagine if I could go to that factory and I can target the manufacturing system itself. What if I go and in the manufacturing process, I attach a chip, a very small chip, to every computer that gets manufactured or every phone that gets manufactured in that factory? What if I attach a small chip? So now I don't have to attack your network. I don't have to attack the routers. I have direct access to all of the devices, all the phones, all the computers, everything that comes out of that factory is already broken. Every phone, every device that comes out of a factory is already broken. And this is not a theoretical problem. This is already happening. So this is particularly this is a problem when many of the manufacturing facilities are located in a single location, a single country or a single geopolitical location. Then what you start seeing is that particular country or that particular agency has the ability to target all the factories in that country, in that location, and they're able to now attack pretty much everything that leaves that factory. So we need to be very careful about how we get our products and where we get them from. And then the last kind of attack is attack the person itself. What if I send a phishing email, or I do a social engineering attack, and I can get information from a specific person, right? So these are all the possible types of attacks, and there are definitely more and more kinds of attacks are being generated all the time, but these are typically what we see nowadays. What are the motivations? The first motivation is the oldest motivation, ransom. I kidnap your data, and I say you pay me so much money and I will release your data. It's the oldest kind of attack. So ransomware is the biggest kind of problem that you see today. The second is to destroy critical infrastructure. Again, this works when countries are fighting with each other. Then you start to see inter-country attacks, one country targeting the critical infrastructure of another country. The third one is competitive advantages. Basically, one company, again, or a country could be targeting another country. Geopolitical advantages. I want to know what you are talking about in your meeting between the president and the prime minister and so on. By doing that, I get some advantages, geopolitical advantages, because I know what you're talking about in secret, and I can use that to do all kinds of other things. So that's the motivation. Ransomware is a typical motivation, but there are lots and lots of country to country attacks that are happening now that we need to be very careful about. So look at a typical network. This is what your network looks like. There are nowadays smart fridges, smart TVs, CCTV cameras. In my city, there are CCTV cameras on the road every 100 meters. Right? Every 100 meters there's a CCTV camera. Every apartment complex has a CCTV camera. But none of us know where the data is going. Where is the video being stored? Most of the time, that video is stored in some company's cloud. What is a cloud? A cloud is just a set of, is a data center owned by that company. And where is that company located? Where is the data center located? Most of the time, the data center is located in a different country. If you buy a lot of these products from companies that are located in a single country, and all of the data, or the video camera data, for instance, is all going to a data center located in that particular country, then you can easily imagine now, if that country ever wanted to attack your country or us, they now have all the data from all the CCTV cameras available. Now, I don't have to, remind you, there's a lot of geopolitical problems happening at the moment between India and China. If you can imagine, then what an advantage something like this would be like when you own, or you're able to control access to what the kind of video cameras that you see, the CCTV cameras that you see on the roads and apartment complexes, the kind of advantages that you get when you are able to attack those cameras. The same thing applies to your TVs. A lot of the smart TVs have a webcam in them. Imagine what you can do, what an attacker can do if they're able to control the webcam and they're able to look into your house. They know now when and at what time do you leave the house, when do you come back to your house, and so on, and they can use that for stealing your house. Stealing your house would be the least of the problems. What if they start to attack a lot of other things, your money, your bank accounts, and so on? So there's a lot that happens in our devices today. All of these devices are then connected to a router, a Wi-Fi router, or in a manufacturing setting, they're all connected to an industrial switch or an industrial router. And then all of this data then goes to a cloud, typically public cloud or a private cloud. And we don't know where they're located, typically maybe in some other country. And so all of this data then is then looked at by some user. Now, we need security all over the place. You may not know it, but a lot of the smart TVs today that you buy, all of them have the same username and password for logging in. You can actually log into your smart TV, and every manufacturer has a certain username and password for logging into the smart TV. Now, if you buy a smart TV and you connect it to the, your Wi-Fi router, so now your smart TV is connected to the internet, and if you do not change the username or password on your smart TV, then anybody now has the ability to log into your smart TV from the internet, from outside your house. Now, again, going back to the CCTV cameras, a bigger problem there, and I'll actually show you an example of how to look into what the CCTV cameras are looking. So as you can imagine, that's the, we need security to all these layers. Who is the user who is looking at this data? What kind of protection is available in the cloud where all these video data are stored? How is your switch or your router connected? Especially think about a manufacturing facility where all of your devices now are controlling the manufacturing equipment. What if I could target that and attack that, right? So we need to be very careful about how we are protecting those equipment and all the devices themselves. So you need security all through the stack. Defense in depth. This is called defense in depth. You need to be able to secure everything that's in the path here. So let's take an example of an IoT attack. Mirai was an IoT botnet. A bot is just a way to describe a zombie, a device that's taken over by an hacker is called a bot, and a botnet is a network of these bots. What the Mirai botnet did was that it's a malware. Mirai is a malware. And what it did was it just scanned the internet for IP addresses of IoT devices. And I will actually show you how to do that as well. So you can scan the internet for the addresses, IP addresses of all the IoT devices. And as I mentioned, a lot of these IoT devices do not have enough security, and they all use the same username and password. Most of the time from the same manufacturer use the same username and password. So what Mirai did was that it had a list of these common usernames and passwords. So let's say you buy a Linksys router, the username is admin and the password is Linksys, or if you buy a D-Link router and so on, right? So similarly, your smart TVs and your smart light bulbs and so on, they all have common default usernames and passwords. So what Mirai did was it had a table of these default usernames and passwords, and then it just simply attacked them. It logged into them and changed the firmware. Right. So what it did was it logged into them, changed the firmware. Now, what did the new firmware do? The new firmware, now all of these IoT devices have become part of a botnet. Now, if I want to target a server, then what I do is I take all of these IoT devices and I make them send lots and lots of data. I make them target a particular server. Right. When I do that, I immediately bring that server down. The server dies, right? The entire network dies. What I've done is I've basically created a network of zombie devices, a network of zombie smart TVs, a network of zombie smart light bulbs. Imagine your light bulb can attack a factory, right? That's the kind of world we live in today, where a simple light bulb that's connected to the internet can be converted into a zombie that can then go out and attack a big factory or even attack a different country's critical infrastructure like electrical grid, for instance. So this is the Mirai botnet. It is in fact still active, and it is targeting a lot of targeting a lot of IoT devices, making a zombie network botnet, and targeting specific servers when needed. So next time you buy an IoT device, next time you buy a smart TV or a smart light bulb, think about what you're doing, see how to secure your devices. Let's talk about a different kind of an attack. This is called BGP is a border gateway protocol. The BGP protocol is how the internet builds a map. BGP is like Google Maps for the internet. So when you go to your browser and you say google.com, how does your browser know how to go to google.com? So there is a map that it follows. The map basically says from your device, from your laptop, you need to go to this router, and then from this router you go to Airtel's router, and then from Airtel's router you take this cable that goes under the sea from India to, let's say, Singapore to Hong Kong, and then from Hong Kong it may go to Japan, and Japan to Los Angeles to San Francisco, where Google is located. Google servers may be located. Now, how does it know how to go all of these ways? And that's driven by the BGP protocol. Now, imagine if I can attack the protocol. If I can attack the protocol and say that instead of going this path, why don't you take the path to Russia, to China, to North Korea, and then go to google.com? And that's a common kind of attack that happens all the time. Now, you may not think about this as being a problem when you go to google.com, but what if I was going to hdfcbank.com, and instead of going from here to Bombay, where the HDFC Bank's website is located, my data actually goes from my computer to China, to Russia, to North Korea, and then back to Bombay to HDFC Bank. What can the attackers in China or Russia or North Korea do with that data? They can easily see what kind of information you're sending to your bank, and then they can target that. This is a very old kind of attack in the year as you can see, this is the 1997 incident. At that time, it was an accident. Accidentally, somebody set up a routing protocol in a way that they took all of the traffic to themselves, and they created an entire black hole for a big part of the internet. But it was an accident in 1997. In the year 2018, it's not an accident. It is actually intentionally done that way in order to steal information, and not just to steal information, but it is also to hijack a lot of your information. This continues to happen today. So we need to be careful about how countries manage their network. A lot of our neighbors are very interested in our data. So this happens all the time nowadays. So. Another kind of attack that we see nowadays is attacks on the industrial control systems, electrical grids, nuclear plants, and so on. So the nuclear plant in Tamil Nadu, Kudamkulam, was hacked last year. Luckily, or by design, the network, the administrative network, and the nuclear network were not connected to each other. So the administrative network was hacked, but it did not extend into the nuclear network. But the Iran's nuclear program was not so lucky. So what happened was that a country now believed to be the US and Israel together, they built a malware called Stuxnet, Stuxnet. They built a malware called Stuxnet. They put it on USB drives, and then they made it available to some people in Iran, somebody who had access to the Iranian nuclear program network. And they connected that into the network. And what this malware did was, when you look at a nuclear plant, they have something called a centrifuge. A centrifuge rotates really, really fast, and it separates the nuclear capable uranium from the non-nuclear capable uranium. And then that centrifuge is how you basically separate out all the bomb grade uranium. So what this malware did was, it made the centrifuge go just a little bit faster, right? Now you might think there's a monitoring system that should have detected this, that the centrifuge is going faster than it is supposed to. But what the Stuxnet did was, it specifically constantly sent data to the monitoring system saying everything is fine, everything is fine, everything is fine, everything is fine, there's no problem at all, everything is fine, everything is fine. So the monitoring system did not detect that the centrifuge is being attacked, right? Because the malware specifically blocked that part. And instead, the malware just kept rotating the centrifuge faster and faster and faster until the centrifuge physically broke down. It actually just completely broke down, and the entire Iran's nuclear program was set back by 10 years, or many years actually. So the entire Iran's nuclear program went down because of a malware that is believed to be by Israel and the US. These kinds of attacks happen a lot. Russia constantly attack Ukraine's electrical grid. For instance, they turn off the electricity, especially in winter when it's very, very cold in Ukraine. They turn off the electricity, causing a lot of problems to Ukraine. These kinds of attacks happen very often. And very often this is targeted by countries, one country attacking another country. There are other supply chain attacks, and even for us, software supply chain attacks. When we have to do an assignment, what we do is we go to github.com or we go to Google and we search for some library, and then we just use that library in our assignment without thinking about what that library does, or a new module in Python or something that we just don't understand, and we may just use it. But let's say you do the same thing when you build a product. Let's say you build a smart TV, and instead of writing the smart TV software from scratch, you went and downloaded the smart TV software and just put it. What is on that software? We don't know. A lot of the time, these softwares have a lot of problems in them, and many hackers have actually attacked the software and inserted malicious code in them that we then just simply download without verification, and we use it in our products. That's a big problem. So I talked about attacking IoT devices. Here is how you do it. Shodan IO is like Google for IoT devices. In the same way that you have a Google search engine for searching whatever you want, Shodan.io, Shodan.io, Shodan.io is a search engine for IoT devices. So you can go to Shodan.io and you can quickly search for IoT devices. So for instance, I searched for webcams in India. I searched for webcams in India, and I immediately got a whole list of webcams that are connected to the internet, directly connected to the internet. Now, not only do I have a list of webcams, I can actually see the video from those webcams. And that is what I'm showing you here, is somebody in Delhi. As you can see in the top here, it says the IP webcam from is connected in the Bharti Airtel network. It's in Delhi. And this one, I can actually see the video that the webcam is able to record, right? I don't have to do anything. All I did not even hack the webcam. All I did was I searched for the webcam in Shodan.io. I searched for all webcams in India in Shodan.io, and I got a webcam in Delhi that actually is just openly publishing the video, right? And there's a whole bunch of other video webcams that show up in this list. So here's a search I ran. I said country : in, which is India. In India, search for all webcams. That's all I did, and I got all of these. Right? You can search for all kinds of stuff. You can search for electrical grid, right? If you want, you can search for nuclear plants. All kinds of stuff show up in here. So here's another example. I search for traffic lights. There are traffic lights that are connected to the internet. So I searched for traffic lights. It found one traffic light in Korea. As you can see, it's the Republic of Korea. This is South Korea. It found a traffic light. And here's the interesting part about Shodan. Not only does it show you the device, it actually shows you what vulnerabilities that device is susceptible to, which means that what are all the problems in that particular device. So this traffic camera in this traffic light in South Korea actually is running a web server, an old version of a web server that has vulnerabilities in it. For instance, the CVE 2010 means that the bug was found in 2010, and this traffic signal in South Korea had not yet fixed or upgraded to the new version of the software, which means that all I have to do is I can easily attack this traffic signal in South Korea, and I can control the signal in any way I want. I can change the lights, I can do whatever I want at any point in time, because Shodan just showed me what vulnerabilities that traffic signal is susceptible to. I did not do any hacking. I didn't do any hacking. I didn't do any coding. I didn't do any programming. All I did was I used a search engine and I found all kinds of information. So this is the level at which we are today, where so much of our IoT, of our devices are connected to the internet, but they don't have security in them, which is a very big problem for us. So there are many more types, social engineering, all kinds of government monitoring, all kinds of stuff. So what is the problem? The problem is that securing our systems have become very, very hard now. Software is very complex. Hardware is very complex. There's a lot of people interactions. There is a lot of different components. There's the cloud, there is the devices, there's phones, servers, there's containers and VMs and Kubernetes, and there's just so many things that are there in order to build a system that all you have to do is find a single hole. Find one hole, and a hacker can easily attack your system. So that's where we are today. Now, here's an interesting comic that will be interesting. So when we hear all of this stuff, immediately we would all think, hey, let's just encrypt the data. We'll just put these security system and that security system, and we'll put this cryptography and all kinds of stuff. But in all of these things, there is a single problem, which is the human being. No matter how much cryptography and how many keys and how much algorithms you apply, it is always possible to break all of those, because human beings are a weak link in this process. So as the cartoon says, all you have to do is hit the human being with a spanner, and he will give you the password. Even if the password is very, very long and very big and very secure, all you have to do is just hit him and you'll get the password. So I hope that was interesting, the kinds of attacks, the kinds of problems you're saying. So what is it that we can do? If you've all seen these Hollywood movies, big Hollywood movies, where they try to attack a bank, and what they do is they turn off the entire city's electrical grid, and they do all kinds of stuff so that they can take $150 million of money. Now, in order to do all of that stuff, it must have costed them at least $10 to $20 million to do that much work. But there is value in doing it, because they spend $10 million to hack and they get back $150 million. But imagine if they have to spend $10 million to hack and they get back $11 million or $12 million back. There is no return of investment in such a scenario. So what is it? It's the same thing applies to us also. If we make it very expensive for the attacker to attack us, then there is no reason for them to attack us, because the amount of money that they will spend, or amount of time that they will spend in trying to attack us, the value that they get out of it will be very little. So Here is a bank safe from the year 1900. So if you look at this, in 1900, it would have been a very good safe, but I would not use this today. Right? This is not the kind of security I would use today. I would instead use a security like this today, which is actually a safe used in a European bank today. So what the bank on the right hand, the bank vault on the right hand side does is it makes it very difficult for the attacker. But if the attacker really wants to attack it, they will spend a lot of money doing it. But they have to spend a lot of money doing it. They have to spend a lot of time planning all of this out, and only a small number of people then would actually attack it. So it's not that it cannot be attacked, but the value of attacking it will be much smaller for some, for a local thief, right? They have to spend a lot more money to attack it than what they'll get back from it. So the same thing applies to us also. We need to make it harder and harder for an attacker to attack us so that there's no value in them attacking us. So I just want to say, since you're all college students, I just want to say, if you want to enter the cybersecurity field, here are some interesting roles. Black hat is typically referred to people who try to attack, or hack devices and networks and so on for their own benefit. Please don't be a black hat, right? Then there are defenders, the blue teams, who try to prevent things from happening. The red teams are white hat or penetration testers. These are the people who actually protect, or what they do is they test the network and then they see whether a network or a device is secure. They're the product builders. We are the people who have to build the products, and we try to see how to protect the product. And there's the forensics and malware analysis. They are like the police. Somebody's already hacked, then they come in and they try to figure out how did the hack happen, what happened, how can you make it better, and so on. So I would strongly recommend studying cybersecurity, because as you can see, with the kind of neighbors we have nowadays for India, we need a lot of people who can handle this. In fact, yesterday or day before yesterday, the government sent out a notice saying, please be careful, there could be a lot of phishing attacks being sent out using the COVID as a motivation. There might be a lot of phishing attacks. There's lots of attacks going to happen. They're already happening and they're going to happen in the future. We need all of you to work in the cybersecurity area so that we can build a much more secure future. So I want to talk about how to defend. We looked at a lot of attacks, and it looks like, man, there's so many attacks, and we may get depressed about it and say, what is the point of building anything? But let's not look at it that way. Let's see how to build or protect ourselves. So the key part that I want to talk about is secure development. A lot of us, especially when we are in college, we just use the fastest way to get our assignment done, right? We just use string copy, mem copy, whatever it takes, and we just quickly do it. But when you're building a product, when you're building a smart TV, we cannot work the same way. We have to make sure that every problem that is there is properly fixed, right? Try not to use C if possible, because there's a lot of incorrect ways of using C, and that causes a lot of problem. Newer languages are much more safer. You can use Go or Rust and so on, much more safer. But if you have to use C, be careful about how you're using the libraries in C, right? It's very important that we understand what functions we're using, what are the negative parts of the functions. Everything needs authentication and authorization. We need to be sure that we need to say who can access what. Don't build a product where your passwords are easy to guess, right? Don't build a product where with one password, everybody can log in. Just like how you all have different Gmail user IDs or your college user IDs and passwords, similarly, when you build a product, there needs to be multiple user IDs and passwords, and each user should be allowed to do only one thing at a time. So role-based access control, based on the role, people should be allowed to do only specific things, right? And there should be an ability to audit everything that is being done. There needs to be integrity check. We'll see what this means. What is an integrity check? But when you ship a firmware, the firmware needs to be signed, cryptographically signed, to say that this firmware has not been hacked, right? And when you boot a device, we should be able to verify that the device has not been hacked at any point in time. So if you have a laptop, I should be able to ask your laptop saying, is your laptop running the right version of Windows? And you should be able to tell me, yes, I am running the right version of Windows, I'm fully updated, nobody's hacked me, and so on. We'll see how to do that. I'll show you a little example. There's something called threat modeling. Threat modeling is the idea of taking a software or a hardware and then saying, how can it be attacked? what are the different ways that somebody would actually attack it? Today, when we build a product, we always look at it and say, I want to build a TV, so the TV must show these channels, it must have HDMI and so many speakers and all of this stuff. But we never think about the fact that what if the TV was hacked, right? So this is an important part that we need to see is something called security testing, right? We need to think like an attacker. How do I break the system? What would an attacker do? How would he come back and attack the system, right? We need to know how to do this so that we can build products that work better, right? That we build a product where security testing is an integral part of our whole building. So in college, all of this may seem very theoretical. You may say, I don't know what all of this stuff is, but just keep it in mind when you go to start working. And when you start working in a large company, when you build your own, I'm hoping a lot of you will start companies. India needs a lot of entrepreneurs. I'm hoping that all of you will start your own company and build your own products. When you do, please remember that your product needs to do a lot of security testing. You need to understand all of these, especially when you start building for IoT, small devices, and so on. A lot of these small devices are very open, no security at all. So please think about that. So this is the whole idea of how to be a good difference. Is you take secure development. All of us have, we all use fingerprints for logging into a phone. Think about it. Can those fingerprints be taken out of the phone? How did the phone manufacturers design it? What if they get access to our fingerprints and so on, right? So some of these things, how did they think about the security of all of this? We need to think about that. Security-focused design, security-focused development, security-focused testing. Right? You do all of these, then we can slow down an attacker, right? For an attacker, it will not be as simple as what the Mirai botnet did, which is use default username and password, right? So it should not be that way. We should make it very, very expensive for the hacker to attack us. That's very important. So this is all about security, right? But let's talk about trust. Now, security, as we talked about, is a perfect state, right? It's very hard to build a software or a hardware that is completely secure, that is 100% secure. It's very difficult to do that. But we all know what trust is. Trust is, let's say you have a friend, you have two friends. If I ask you, which friend would you trust? You will definitely answer saying, I trust Vijay, I won't trust Vivek, right? Or you may say, I trust Vijay, I will trust Vijay with my car keys. I will not give Vivek my car keys, but I will trust Vivek for a cricket match, right? If I want to play a cricket match, Vivek is better than Vijay, and so on. So we know exactly who among our friends are good for us in what way, right? We know to which friend we will give our bike keys, to which friend we'll give our car keys, to which friend we will call when we have to play a cricket match, and so on. So we know exactly what our friends are capable of, and we trust our friends to do the right thing. The same thing needs to happen with our systems also. We need to be able to say, I have a smart light bulb. I know exactly what this light bulb is going to do. Is it doing exactly what it is doing? Right? And that is a very important thing that we need to understand about all the devices that we have. We should be able to trust our devices in the same way that we trust our friends. We should be able to say, this device, a smart light bulb can only do this, it cannot do that, it should not be doing that, right? A smart TV can only do this, it should not be doing that, and so on. I want to give an example. Here's on the leftmost, there is a manufacturing site. They build something and then they send it to the transport, which will then take it and then send it to all the offices or sends it to your home, right? Now the office has to trust the manufacturer. Because whatever is happening in the intermediate, like let's say you buy something from Amazon, somebody that in the courier office may then take your package, they take your phone that you were shipping and put something else into it. They may put a brick or something into it, right? What you need is the ability to go and ask Amazon saying, what did you actually ship? Show me what you actually shipped, right? I want to show you an example. On the bottom here is a photograph of a US spy agency. What they did was they intercepted all packages that were being sent from a manufacturer to customer. They intercepted the packages, and then in the middle, when they intercepted, they cleanly opened it, just like a movie, right? This is exactly like a movie. They opened it in such a way that you cannot detect that the package was opened. Then they opened up the box itself and they added a small chip inside, right? Which when the customer receives it, they will not be able to detect that there was a chip there. And then the customer will now use the router as they normally use it, but all the data that they were sending through the router is also getting sent to the US spy agency. This is a real life thing. This actually happened. This was detected, and we got to know about this. But the US spy agency, this is exactly like a movie. It's like the Mission Impossible movies, right? So as US spy agency actually did this, they intercepted all the packages. They added a chip in there that nobody could detect, and they were able to package it again as if nothing had changed, and then they sent it back. So in these cases, how do you detect this kind of stuff? How do you detect that something has been tampered in the process? So you cannot trust the intermediate, right? You cannot trust the intermediate. So every time that you have a device, an IoT device or your laptop or anything, you need to ask two questions. How do I know my device is running the software that I think it is? I think it is running Windows 10 with so-and-so software. Is that really what is happening? Right? And the second thing is, how do I know my device has not been physically altered? I bought a phone, and let's say I bought a phone from Oppo, let's say, right, or Redmi, and then Redmi shipped the phone to me. Did somebody in the middle open the phone, put a chip inside, and now and then packaged it back and sent it to me? If they did that, can I detect it? Can I detect that the phone is not exactly the same phone that was built in manufacturing? That's how do I find out if somebody has tampered my phone or not? Very important questions to be asked. Is your software being tampered? Is your hardware being tampered? That's the two questions. We need to know if your software and your hardware has been tampered. Now, I'm going to talk about Linux. Hopefully, you're all college students. You should likely know about Linux. So let's say, I'm running the Linux kernel. There's a lot of applications running. How do I know that the Linux kernel is running exactly what I thought it is running? So in order for that, what happens is there is the grub bootloader. The bootloader verifies Linux, right? Bootloader verifies Linux and says, this Linux, I certify this Linux is running exactly what Linus Torvalds himself shipped, right? Or Ubuntu shipped or Red Hat shipped, right? But you have a problem. How do we know that the bootloader has not been hacked and that the bootloader is not simply saying that the Linux has, is the right version of Linux, right? So in order for that, what happens is then there's the BIOS. The BIOS will verify the bootloader and say the bootloader is perfectly fine. I will notarize saying that the bootloader is fine. Then the bootloader notarizes the kernel and says the kernel is fine. But we have a problem again, that how do we know that the BIOS is running the right version? We will say, maybe Intel, the processor, can verify the BIOS, but then who verifies the processor? So this is called a chain of trust. If you think about it in real life, I have 4 friends, right? I have Vijay, I have Vivek, I have Ravi, and I have Sundar. I have 4 friends, right? Now I don't know Sundar, right? And I don't know Ravi, I don't know Vijay, I only know Vivek. But Vivek tells me, you know what, I trust Vijay, so therefore I will trust Vijay, right? Vijay tells me I trust Ravi, therefore I will trust Ravi. Ravi tells me I trust Sundar, therefore I will trust Sundar, right? So this is how in real life, this is how we form friends. How do we form friends in real life? We always know one friend or 2 friends, and then they will introduce us to more people and more people and more people, and that's how we form friends. Now, if you think about the same thing in the context of LinkedIn, that's exactly how it works on LinkedIn. You have the first level, second level, third level. You build a network based on who you trust, right? You have a small group of people you trust, and then from there you expand out to larger and larger groups. If somebody comes and says, hey, do you know Sundar? You will say, I don't know Sundar that much, but I know Ravi, and Ravi knows Sundar, and Ravi says Sundar is a very nice guy, so therefore I think Sundar is a nice guy, right? We build a chain of trust in real life. We need to do the same with our hardware and software. We need to build a chain of trust. We need to know something that we can easily trust, and then from there we trust everything else. That something that we easily trust is called a trust anchor. A trust anchor is a small chip, a very, very small chip that is there in a lot of our devices today. All of our Android phones, Apple iPhone, your laptops, every one of them has a small chip in there called the root of trust, a trust anchor. Right? Here's an example: Google Titan, Microsoft as Cerebrus, Apple as T2. All of these, not only in our phones, they're also there in the cloud. All the AWS or Azure, the servers in the cloud, they all have these chips, the root of trust, small chips, and these chips verify that the processor is doing the right thing, right? And so that's how we form the start of our chain of trust. right? So, the root of trust is the only one that we will trust. Then the root of trust will then tell us that the processor is fine. So therefore we trust the processor. The processor then tells the BIOS is fine. Therefore we trust the BIOS. The BIOS then tells the bootloader is fine. So we trust the bootloader. Bootloader then says, I trust the kernel. Therefore we trust the kernel. Right? Just like in real life, how we have a small group of friends and then we expand our network. Here our only friend is the root of trust, the trust anchor, Apple T2 or Microsoft Cerberus and so on. That's a real friend. And then from there, we form a chain, right? This is how we build trust in our hardware. This is how we build trust in our software, just like how we do it in real life. So how would you trust a device to tell you it's trusted? If I came and asked you saying, hey, Ravi, can I give you my bike keys and be sure that you will not break it? And Ravi is always going to say, yes, I will never break your bike, right? Give me your keys. I will definitely not break your bike. So we cannot go to a device and ask that question. Instead, we go to the trust anchor and we ask that question, and the answer must always be yes, relax, right? Relax, everything is fine. So I want to recommend this group. It's called TCG, Trusted Computing Group. Trusted Computing Group has this TPM, Trusted Platform Module. The Trusted Platform Module is the API, and a lot of chips are built based on this API. There's also a software version of this Trusted Platform Module for emulation. This is how we trust our devices. So when I say, the Apple T2 and Microsoft Cerberus and so on, they're very similar to the Trusted Platform Module. In some cases, they even support the same APIs. If you build your own company, if you start your own company, and I really, like I said, I really hope all of you would start your own companies, build your own products. This is a chip that you must add in all of your products. A very, very cheap chip, right? The TPM chip is a very cheap hardware in all of your devices, your IoT devices, your laptops, your hardware. Make sure that you have a TPM chip in them and use that chip for verifying your software and your hardware. How do you do that? In your chip, you will find these registers, PCR. PCR is a platform control registers. In these registers, you will see a hash based on how you boot up. So the hash number 0, register number 0 has the hash for the BIOS, right? Register number 2 is the ROM, and register number 4 is the master boot record, and so on. Registers 8 to 15 is the operating system, the Linux kernel, the applications, and so on. Looking at these hash values, we are able to tell if we trust the device or not. So we can go back to Ubuntu and say, hey, Ubuntu, give me what will be the PCR 0 value if I have a very valid device, right? And Ubuntu will be able to tell you that. Or let's say I have a Dell laptop. I can go to Dell and say, Dell, for this laptop, what should be the PCR 0 value? And they will give me that value. I can verify that the value is the same, and that way I will know that nothing has happened. Nobody has tampered my laptop since Dell shipped it to me from the manufacturing, right? If the register values have not changed to what they were in manufacturing, I know that my device has not been hacked or not been tampered with. So how do we use this today? Today, a lot of the time before, my office device, for instance, my office laptop and all, before I can connect to the internet, it will verify the status of the device. If my office software thinks that my laptop has been hacked, it will not allow me to connect to the internet at all, right? So it will make sure that my device has not been hacked, and this is exactly how it happens before it allows me to connect to my company's network. The same thing when you have to do financial transaction. Let's say you want to connect your bank account, or if you want to connect to a stock, your mutual fund account, and so on. Then those companies, they can verify that your device has not been hacked. Is your phone working the same way as it was in the manufacturer's factory, right? If the phone does not match what was in the factory, then the bank's website can stop you from accessing the bank, because it will say that your phone has been hacked, your phone has been tampered with, and so I cannot trust your phone, right? So then please go buy a new phone, or you go reboot your phone, reflash your phone, something, right? But basically now you have a way to trust your devices. Now remember what I said, security cannot be 100%. There'll always be somebody who's going to hack it. But what we're doing here is we're not stopping the hack from happening, because we know the only way to stop the hack is to make it very, very expensive for the attacker. But for attackers who have a lot of money, let's say, or some countries, for instance, the countries have a lot of money. If they really wanted to target you, or they want to target other countries' infrastructure, they have a lot of money to do that. So they will easily do that, right? But what you're doing here is you're making sure that if somebody has attacked you, right, then you can easily detect it. Right, what you're doing is you're quickly detecting that somebody has attacked you. Now, remember I told you that the government of India has put out a notice saying there's a lot of phishing attacks going to happen, and so on, right? So at that point, I want to be able to say, is this email valid, right? Has my device been attacked? Has my phone been attacked? Has my laptop been attacked? And I will be able to get that information. And how do I get that information? I get that information by the trusted platform module, right, that your devices are already shipping with. So you should definitely ask these questions about, your devices. Are they running the right software? Are they running the right hardware? Have they been tampered? Have they been hacked? How do you know your smart TV, your smart light bulb, your fridge, smart fridge, whatever that you have, or any other IoT devices? A lot of IoT devices that are doing agricultural facilities now. They're controlling when the water should be pumped, right? And all of that, you should be asking those same questions. So then you will get an answer saying, yes, your device has not been hacked or your device has been hacked. Okay, so here's a free book. This book will tell you lots and lots about this chip. Like I said, the chip is very free, very cheap. The chip is very cheap. The book is free. So you should definitely go read this book, and you should learn how to use the TPM today, because this is how security can be controlled in our devices today. So I want to summarize. We're at the end of this talk. So we looked at a lot of things today. We looked at a few hacks. We found out that securing a system is very hard, right? So our real goal is to make it expensive for the attacker, but attackers with a lot of money can still attack our system. So what we want to do is we want to follow standard secure development practices, right? You need to use the right language, use the right API calls, right? Use the right function calls, and so on. Don't download random libraries. Don't download random software onto your phone. Understand where the software is coming from. Use them properly, right? Especially VPN software. A lot of us download VPN software. Again, a lot of those VPN software come from a single country. And the VPN software can see everything that you're sending. They have complete access to your bank account, your login details in your bank, and so on. So be very careful when you download VPN software to your phone, because that VPN software can read your passwords, right? And you will not know about it. Okay, you need to build trusted systems. We need root of trust, right? The small chip that we can all trust. The closest of our friends is the root of trust, right? And then we build the network of trust from there. And we need to be able to establish that trust, just like we do in real life. We do all of this in real life automatically. We have only a very small number of really, really good friends, and then everybody else from there is a network of friends. We need to do the same thing with our hardware and our software. We should trust very little, and then ask those to trust others, right? We need auditable systems. Auditable systems means that we need to be able to tell who is using the system at what time did they log in. If you've seen any of these Hollywood movies with spies and so on, they're easily able to find out. They'll say you have 5 minutes to do this, right? In 5 minutes it'll detect that something is wrong. Similarly, for us also, we should be able to find out every attack. Did somebody attack a bank? We should be able to know that very quickly, right? We should be able to know that somebody attacked the bank. When did they attack it? How long ago did this happen? What data was leaked? Immediately we should be able to shut down the bank servers, and we should be able to clean up everything, right? Auditable systems is very important. So this is a call to action. All of you, I would really like it if you all took up this security as a key thing for your life, right? And started to think about security in whatever you do. Don't just build some software just because you're building software. Think about the security. Think about how attackers will target your product, both your your hardware and your software. Think about all the devices you have in your house, your Wi-Fi routers, your TVs, your phones, your laptops, your desktops. Think about how all of that, and see, are they being attacked? Look at the Shodan IO, right, and see. You can, as that showed, right, you can easily find out all these devices. Imagine I can find CCTV cameras on Shodan. Imagine what other countries can do to our infrastructure if they're able to hack our infrastructure like this, right? Very, very important. Hope this was useful to all of you. If you have any questions, I would be very happy to answer. I'm looking forward to working with all of you in the cybersecurity field. Thank you very much.
Thank you so much. Thank you so much, Karthik sir. Thank you so much. I'm sure there will be several questions. So you can either write your questions in the question box. Anybody who has got questions, please write it in the question box, or you can raise your hands and I will unmute you. If you raise your hands, I will unmute you for the question for you to ask the question directly. So firstly, I will go to the questions box to check any question. Okay, Mr. Amitav Chattopadhyay asks, so will you please send the URL or tell the URL of the book so that I can download and study it? So you mentioned about a book. Yeah.
Yes, yes. So definitely the book URL is there. I can send it to you, Professor, and then you can send it out, or I don't know how we want to do
Definitely.
this. We can definitely
No,
do that.
yeah,
So
yeah, you can do that. You can do that, sir. If you send it to me, I will
yes,
definitely. I will just ping you once in
yes,
WhatsApp maybe after this, and you kindly send it to me. I will forward it to all listeners, everybody.
absolutely, sir. We'll do it.
Thank
Yeah.
Thank you so much, sir. Another question. Okay, I'm just looking for the question. Uh, okay, Mr. Basant Kumar Bimal. He asks, sir, how to start? I am absolutely a beginner regarding Linux and hacking field. So where
So
from to start? He asks.
yeah, so there are a lot of different resources available. The best way to do it is to get some kind of certification. So the ones that I would suggest is called Certified Ethical Hacker, CEH, Certified Ethical Hacker. It's a very good certification, and it's the beginner level certification. It really tells you what kinds of attacks are there, how to do it, and it will give you a lot of examples. And the certification is very useful also. So the very first step to becoming a beginner in the whole hacking area is to get this certification. So I would strongly recommend that one, Certified Ethical Hacker, CEH.
Okay. Thank you so much, sir. So another question is, sir, what do you think about? Just a minute. The question. There are so many questions coming up at a rapid pace, so I'm just losing out
Okay.
on that. Sir, Mr. Debduti Dolui, he asked, sir, what do you think about processor level vulnerabilities like meltdown, zombie load? Can they be secured using TPM?
No, they cannot be secured using TPM, unfortunately. So the problem with the processor level vulnerabilities is no real, fix. We've been fixing them by controlling hyper threading and all kinds of caching blocks and so on. But yeah, it's very difficult. They cannot. I don't think they can be fixed with TPM. In fact, Intel's idea of a secure, enclave, the SGX, right? Even that has been hacked. So at this point, it's very hard to tell what a processor level, how to secure a processor level one at this point. Yeah, no, I don't think a TPM can protect from processor level hacks, unfortunately.
Okay, sir. Thank you. So Professor Arnab Basu asks, while downloading several standard apps, it asks for giving permission to access the files in our mobile set. Why do they need this? Is it even safe to use the well-known apps?
Yeah, exactly. So this is the fundamental problem. A lot of these apps, they just ask for permission because they can ask for permission, right? And they don't really need a lot of this information, and they just ask. And unfortunately, we have no control over it. I think Android is also now getting better. Google is now getting better at providing us control. So I think the latest version of Android, which is in beta now, you have the ability to say give permission just once, right? Not all the time. So it will not have the ability to read it all the time. So you can give permission just once, right? And so that way, what happens is when you specifically need. So for instance, in my phone, that's what I do is all these mobile, the video conferencing apps, I don't give them directly permission to use my webcam, right, or the camera on the phone. I give them permission when I need them. So I only say I give them permission once for a particular meeting, and then when the meeting's over, I go back and turn it off, right? But this is a very good question. I think this is a very important point also, that a lot of these applications are asking because they just don't put in the effort to say what they actually need. Google allows them to ask for all of these things in bulk, right? All permissions in bulk, they just go and ask for it. Unfortunately, we don't have any way to control this except hoping that Google does something better, right? And like I said, the Android beta seems to be better that way. So let's hope that apps also change.
Okay. Thank you, sir. That is really an interesting point. Sir, Mr. Ayush Pallab Gupta asks, are there any loopholes inside firewall built by Microsoft?
Oh, that's I see. I'll tell you this: any software has a problem, right? Are there? If you ask me for specific ones, I may not know them right away, but I'll tell you that firewalls built by a lot of the firewall companies have problems, have security vulnerabilities in them, which is very ironic, right? I mean, you're using a firewall to provide security, but the firewalls themselves have security problems. Unfortunately, they're also software, they're also hardware, and so I would be surprised if the Microsoft firewall did not have any problems, right? I don't know of any, but I would be very surprised if it did not have any problems.
Okay, thank you, sir. So Professor Partho Paul, he asks one question on TPM 2.0. Now, if our banks, so our banks are verifying our devices and checking if they are the correct ones, like normally we can log into our bank account from different devices. So I'm not sure whether his question is when.
Yeah, I think I understand what he's asking. Today, the banks do not do that, not to us at least, right? So this is only happening at very, very critical levels, right? It's not happening at the consumer level today. So the banks do not check our devices at all. So this is happening, when you have to do, interbank transactions. Some of them are, definitely much more security happens than at our level, for instance, right? So yeah, banks have to do this with us. Today they don't, because of the exact problem that the professor is pointing out, that we use multiple devices. They don't know how to do this. That level of API and that level of usability is not there today. But it happens at the industrial level, right? And between banks and so on. So, and between other areas. And like I said, my company does it for when we connect to our company network, right? They definitely verify my laptop. So.
Okay. Yeah, thank you, sir. So Mr. Anirban Sinha, he asks, a year ago, I used NSS leaked tool, Eternal Blue, and double pulsar. It was able to detect the SMB vulnerable devices. So can there be any future threat of any similar vulnerability?
Yes, all the time. There are vulnerabilities happening all the time. I think the question is, who finds them? How long do they keep that vulnerability a secret, right? A lot of the times what happens is the spy agencies, so of course, we have our own, there's the NSA and the CIA in the US, there is, the new KGB in Russia and China and all of these, right? So they all find these hacks, right? These vulnerabilities, but they don't tell people, or they don't tell the company, because if they tell the company will fix it, right? And instead what they do is they use these vulnerabilities to actually do the attacks, right? So again, I would think there are lots and lots of vulnerabilities in our software, and I think it will just slowly come. You can read them in the news, right? In the news you can see many vulnerabilities are being detected all the time, constantly.
Okay, so there are some other questions, but I just want to make this a little interactive. Mr. Anirban Sinha has raised his hand, so I think it will be a good point letting him allow to him to just ask you a question. So I'm just unmuting him. Mr. Anirban Sinha, you please remain on the mic. I'm unmuting you. You are self-muted. Can you kindly unmute yourself and talk? Mr. Anirban Sinha, you have raised your hands. Maybe it is done wrongly then. Okay. Mr. Aman Lama, you are also self-muted. Can you unmute yourself and talk? Because you have raised your hand.
Good afternoon, sir. This is Yusuf Alam. I'm talking from Aman Lama's phone. Right. Okay. I have an out-of-box question. Like when the whole world is thinking about blockchain, right? Because it's more transparent and we can do lots of things with it, right? So why India is not working with it in a vast level? I want just your opinion. Why India is not thinking that? Because the whole world is now thinking about it, right? So I did many projects with different kinds of people, and no one from India is like wanting project help of blockchain. But whenever we are like serving many clients who are wanting blockchain, they are most of all are from foreigners. Why that is so? What is your opinion in it?
Sure. So that's a little bit out of this, but I'm happy to answer, right? So see, we are, so when you say blockchain is just the technology, right? So I know that there are state governments in I think like Andhra Pradesh, for instance, and Telangana also, if I'm not wrong, they use blockchain for tracking land, right? How land is sold and so on. So I believe that is happening. I've seen those news and articles, right? So on how they do it. I think your question is specifically around cryptocurrency, right? Your question is specifically around why are we not using cryptocurrency, and that's one of the
Yes,
use
sir.
cases of that's one of the use cases of blockchain. I think there's a lot of definitely India needs to figure out the regulations around cryptocurrency, right? That's probably something that's not been worked out, and the cryptocurrency is it's also, again, if it's difficult to track, then the question is who is using the currency for what purposes? Is there money laundering happening? How do you track all of that? So all of that also needs to be figured out. So I think some amount of it is just regulation, some amount of it is probably around security, around who can use it and for what purposes and so on. Unfortunately, I don't have a visibility to what the government is doing. I'm just guessing. So I don't know why or for what reasons the government is doing what it is doing. So think of whatever I said is just my own guess, right? That's what I would expect.
Okay, so yeah, thank you, sir. There are no more. One more hand is raised. I will allow Mr. Sonak Agarwal. So, Mr. Sonak, you can unmute yourself
Hello.
and talk. Yes,
Hello, sir.
can
you hear me?
go ahead.
Hi. Yes.
So the changing of the default passwords of the smart TV and the bulbs and the routers are enough to secure the server?
That's a very good first step, right? But you definitely need to check your Wi-Fi routers, firewall, for instance, right? Have you updated your smart TVs? Also need software updates nowadays. Can you imagine that? I mean, 5 years ago, we would never have thought our TVs need a firmware upgrade. But our smart TVs need a firmware upgrade. If you have a smart light bulb, they need an upgrade. I know of many cases people have a smart toothbrush, right? And the toothbrush will not operate without a software upgrade, right? So I think that you need to. There's standard security practices. Default username password, changing them is the very first step. You need to keep upgrading the firmware. You need to check your Wi-Fi router logs to see are you somebody attacking, or what is a firewall setup in your Wi-Fi router. If you go online, you can just look for some of these standard security practices that are there to protect yourself.
Thank you, sir.
Yeah.
Thank you, sir. So one last person I will allow, Mr. Avijit Datta had a question and he had asked in the question box to kindly unmute. Avijit, I am unmuting you. You can kindly speak.
So thank you, sir. Just to confirm, can you hear my voice?
Yes, definitely.
You're audible.
Okay, thank you. Thank you for sharing the valuable information with us. I'm Abhijit, currently a third year student from Computer Science Department. I've been with Cisco Technologies for quite some time, and I've been a CCIE in routing switching for past couple of months. So I have two questions for you this evening. And my first question is considering the SD-WAN technology, it's a pretty new technology that's evolving in Cisco. And so there's a vManage, vSmart Controller, and vBond. And one of the requirements of vBond is that it should be on the public side of the internet. So do you think it's a threat because the vBond is one of the components that generally comes in a single point of failure? So if the vBond goes down, the entire network is affected. And my second question is, I found out that there's something called SEN along with the SD-WAN. So SEN, it's a secure extensible network. So could you please explain us more about it? Thank you.
Sure. So on the SD-WAN side, so okay, I'm not particularly familiar. I've kind of seen the architecture for that. So the reason for the vBond being on the public network is because it is the fundamental way that you can do plug and play of your devices, right? So that's the reason why it's online. I don't have the details on its internal, so I cannot. There is definitely by threat modeling, just putting something out on the public internet will definitely cause it to be attacked, right? So I'm sure that the threat model has been handled and that the vulnerabilities are definitely being taken care of, right? So on the SCN, I'm not familiar with that actually, so I'm not able to comment on it, unfortunately.
Okay, thank you, sir. So
Yeah,
I
sure.
think I proceed with the other questions. Do you have any more time, sir? How much time do you have? Like we can have just one or two more questions maybe. one or
Yeah,
two more
absolutely.
questions are there,
Definitely one
in
or
the
two more
question
questions,
box.
right?
Yeah,
Sure.
definitely. So, sir, somebody are looking for some books on Linux and all those things. I will request you, sir, you are sending me the link. With that,
Yeah.
if you kindly send this, I will definitely forward to everyone. So the questions for the books I'm avoiding. Many people have asked for the beginners books for different things. So
Okay.
I avoid those things. So Miss Prajna Paramita Chanda. Here, I'm not sure. She is asking, sir, how can we identify phishing mail? So I think that is here.
Yeah. So that's a very interesting question, right? Because it is hard. Sometimes people say, you can identify phishing mails by looking at typo mistakes, right? Spelling mistakes and that kind of stuff. But it is very difficult. The only thing I would say is don't open any link that you don't know, right? That is number one. Number two is there are services that will tell you whether a link is trustworthy or not, right? So there is a, can I type, if I type in the chat, will it show up? I'm just asking. So
Yes, sir. If you type in the chat, it will show up. If you can type in the
okay,
chat, you kindly select to everybody, like
select to
then
everybody.
chat to
Okay.
all entire audience.
Okay, I don't see that option, but I'll send it also, right? And then we can take a look. So there's a website called Talos Intelligence, TALOS intelligence.com,
I will
right? That, yeah,
LOS intelligence.
yeah,
Dot com.
talosintelligence.com, right? So
LOS.
there,
Yeah.
yeah,
Okay.
okay. So
So
in there,
I've sent it to everybody.
yeah, exactly. Okay, okay, good. So talosintelligence.com, right? So there is something called a reputation center, right? What you do is you take the link and you go put it into the Talos Intelligence reputation center. It will come back and tell you what the reputation of that link is. It will tell you whether the link is a malware, whether it is, it is hack is basically it's a malicious site. Is it a phishing site? All kinds of stuff will show up from that. So you go to talosintelligence.com, right? And then from there you can see the reputation guide. In fact, I would strongly recommend that you send it to all of your family members also, right? Especially your older family members who are not who don't understand technology and so on. It would be very good if you took responsibility for them, right? In the sense that every time they get an email or they get a WhatsApp message or some SMS, if they send it to you and you can verify the link in that, put the link into talosintelligence.com, and you can basically verify what the reputation of that link is. Talos Intelligence will give you a lot of information. It will tell you, like I said, it'll tell you whether the site is trustworthy or not, right? And then use that. So that's how you can do it. It's very difficult to tell from the email itself. There are some guidelines saying that, see if the email has a lot of spelling mistakes, if the email has, and there's some few rules are there. But the phishing emails are also getting more and more advanced, right? So whatever link they have, if they give a link, my strong recommendation is to look it up, and don't reply to random mails. I think that's the key. Don't reply to random mails. If the name of the email is from somebody but the email address has changed, then maybe you should just call them and check with them, right? Just call your friend and say, hey, I got a mail from you, but the email address looks different than what you normally send to me. Is this you, right? And that kind of. And nowadays, the kind of phishing we're seeing is from family and friends that say, I got stuck in this country or I got stuck in this city, especially now with lockdown, right? We're seeing a lot of emails that says, I got stuck. Can you please send me 10,000 rupees because I have no access to my bank, no access to my ATM, all that stuff. Can you please send me so much money and so on, right? In all of those cases, please call them, right? Call the person and verify that they sent it. Don't just click on a link to send it out. The same thing applies when you were using like Paytm or any of the UPI, right? A lot of the times the UPI, somebody says, I'm going to send you money, but then what they're actually doing is they're setting it up so that you end up sending the money. And a lot of people don't see it. They just ask for the the OTP and that kind of stuff, right? So all of this is just a little bit of a common sense that we just have to use, saying read what it is saying. Like in the UPI apps, they say you're paying or you're receiving. So they say, sir, we're going to send you this thing, you just click OK, right? And in fact, what they've done is they've set it up for you to pay them, right? Not for you to receive from them. right? So just don't press them just because somebody tells you to press OK, just because somebody is telling you to press OK. So these kinds of little bit of common sense that we just need to follow. I hope that helps. So.
Yeah, thank you, sir. One last question I will read out, and one last person is eager from a long time to talk and ask you one question. So two more questions I will take, sir. One question is now from Avinash Kumar Chaudhary, Mr. Avinash Kumar Chaudhary. Now with data theft shifting from cardholders to data in transit, what are the best paradigms to guide against this? Okay, so this was the question.
That's an interesting question. So by data theft in transit, I assume person means, like, for instance, there has been a lot of problems with the SWIFT based transfer, right? So this is the IFSC like facility that bank to bank transfers and so on that are there. Or the other way is, of course, the Paytm or UPI based scams, right? In which they basically cheat you and take money from you. I'm assuming that's what they mean, because the card level stuff is not happening anymore. So a lot of with the pins and all that on the card. So again, it's just a lot of this is just common sense from our point of view. From the bank point of view, bank to bank transfers, there's a lot more that needs to be done there. That infrastructure is definitely.
Hello, yes, Anirban, you are muted. You are, sir,
Yes, sir.
please, you
Yes,
are
sir.
unmuted now. Please go ahead with your
Yes,
Yes.
sir.
question now.
Can you hear me, sir?
Yes, Anirban.
Yeah, sir. I have a question about Shodan that you have shown.
Okay.
Using Shodan, I can easily see any IP cameras that are vulnerable. And is it possible to see the IP cameras in my geolocation or similar,
Yes.
like longitude, latitude, in the hotel I am living, such that?
Yes. You can specify geolocation in Shodan.io. So you go to Shodan.io, they have a help guide that tells you how to search, right? And you can specify locations and so on. So I just gave country as India. You can go even closer. You can specify latitude, longitude, which you can get from Google Maps, right? Get the latitude, longitude from there, and you can specify that. Yes.
Sir, another little question.
Yes.
Yeah, sir. I have seen that there are so many public Wi-Fi's, free Wi-Fi's are available in the location, but whenever we are connecting in the same Wi-Fi network, it is really easy to see that devices are connected to the Wi-Fi, and
Yes.
it is more easier than to intercept all the traffics with the end devices that are connected to the network. So
Correct.
how can we disable this? How can we enable the security that the HSTS, that is HTTP strict transport protocol, cannot be bypassed by the man in the middle attack? Is there any way to secure ourselves by connecting in the free Wi-Fi networks?
So HST, you can use HSTS, but a lot of the time HSTS is also set up by the browsers, right? So I don't know if you can directly
Yes.
enable it or not enable it. I don't think you can do it, if I'm not wrong. And HSTS also has other problems, in the sense that if the servers, certificates change, right, then you get into a problem.
Yes.
Or if there's a mistake, then you get into a problem. So I don't think you can do it. My only thing is that normally man in the middle for HTTPS is hard to do unless you start to connect to some VPN and so on, right? So you should not be that worried about man in the middle attack for regular connections to HTTPS sites, unless you're using a VPN, right? If you have a VPN, then it's possible that there can be man in the middle done by the VPN provider itself, right? If they're not trustable VPN providers, right? But
Okay,
otherwise,
sir.
if you can connect to open Wi-Fi and then connect to any HTTPS secure sites, or you can connect to good VPN services, right? And there are lots of good VPN services available. Don't just look in your Android app store for VPN and just download the first one, right? Sometimes it's worthwhile to pay for the VPN service, because the free VPN services are stealing your data most of the time, right? So
Okay. Okay, sir. Thank you.
yeah.
Thank you so much, sir. And I should say that there are around 30 more questions in the question box. So I will definitely, sir, I will take an opportunity to mail you with those questions.
Yes,
If you
definitely.
can answer a few, I will definitely forward it to everyone. It was
No
really,
problem, sir.
really a wonderful session, sir. And I'm sure that the students and the teachers have learned quite a lot. And it is evident from the questions and the nature of the questions that is available in the question box. I'm really thankful to you for coming over here, sir. I'm extremely thankful to you. Over here, I will request Shankhadeep was forced to leave because he had some other meeting. Shankhadeep has organized this, but anybody from the ACM chapter would like to say something at the end? Professor Shobhik or Professor Mrinal? Professor Shobhik or Professor Mrinal, would you like to say something?
Hello.
Yes,
Sir,
Professor
I am
Mrinal.
audible.
Yes,
Yes, sir.
yes, you're audible.
Firstly, thank you, Mr. Kaarthik Sivakumar. You are here. You have accepted our invitation, and I think our students got a lot of knowledge regarding this security and trust. So I have a basic question generally. So you have started maybe our device can be hacked from our mobile, maybe our laptops, then it will come to our router. Maybe after that, it will come in the device where it is manufactured. So if some device is coming from that company and uh, it is manufactured in wrong thing, that means some unwanted chips is there. So is it possible for us? How we will verify this one? Maybe yes, please.
Yeah, that's the hardest problem actually. So it really depends on if the bad chip is added with the manufacturer's knowledge or not, right? If it is added without the knowledge of the manufacturer, then there is a way to detect it, because you can always talk to the manufacturer and find out. If the manufacturer themselves added a bad chip, then no way to tell. Right?
So is there any policy till now to protect this one?
No, I mean, there's not there really, actually. It's not there. No.
Okay, sir. Thank you, sir. Once again, you are here and you have accepted our invitation. Thank you once again from the entire ACM chapters.
When the lockdown is over, hopefully, maybe we can travel and meet in person also. I would really love to come to Jaipur and see all of you.
Sir, thank you so much for saying that. Once this is over, I will immediately send you an invitation to visit Jaipur and visit our students. I'm sure they will be much more motivated. They will be fully, I think they will take the opportunity with both hands. Thank you so much for being over here, sir. Thank you so much. I'm so very thankful to you, and I'm thankful to the entire audience. I'm thankful to the entire audience for this patient hearing, and it was not a patient hearing. It was actually what should I say? It was a full. As long as we heard it, we actually were getting knowledge. We are getting more and more knowledgeable with every minute of it. Thank you so much, sir. Thank you so much, and thank you to all the audience. Thank you to the ACM chapter. Thank you to the students. Thank you so much, sir. Thank you.
Thank you. Bye bye.